Hello, my dear all students. How are you all? I hope you are doing well. Okay, let's start. This is our fourth week of this semester, and in this week, we are trying to know about and trying to do Newton-Raphson method by using C programming. Okay. Uh, at first I would like to talk about Newton-Raphson method, and I hope all of you already did it in the theory course. Though it's a theory course part, but some of my students, I think, not doing uh, theory in this semester, so I want to discuss the algorithms at first. So, what's the algorithm? For any method, we have to start the program by initializing variable, header file, and so on. And as before we did it, you need to take some initial value of A, B, tolerance, and total number of iterations. And as per the Newton-Raphson method, we have a equation which is x1 equals to x naught minus f of x naught divided by first differentiation of x naught, function of x naught. Okay, we already know how to calculate first differentiation of a function of x naught. If you have any type of confusion or any type of query, please let me know. I want to discuss, or I will discuss in the live session. Okay, we have to check the absolute value of the difference between x1 minus x naught. If the absolute value of this difference is less than the tolerance value, then go to step 6 and display the root of that specific equation. Otherwise, you have to swap the value of x0 and or x0 and x1 and repeat the steps until you didn't get the you don't get the your required root. Okay, now go to our programs which I have given for you so that you can do the program easily and can understand the program. Now, there is a question for you, which is a equation, and find the root of this specific equation up to 5 decimal point, but you must use C programming. And the equation is 2x cubed minus 3x minus 6 equals to 0. Okay, now let's start. The solution is given for you. Solution is that you have to include or you have to write the header files, which is stdio.h and math.h, and I had already discussed in the previous session what's the significance or what the uses of these two header files. Now go to our next step, which is a float function, and return a float value, which is the value of the equation, and our equation is 2x cubed minus 3x minus 6, and I enclose it in a function so that we can calculate the value easily. Now another function which is another float function, and it's written the differentiation of first differentiation of this equation, which is 6s minus 3, and this same equation I had already discussed in the theory session. Okay, now go to our next step, which is our main function, and we already know that we have to take some input from the keyboard, which is x0 x1 tolerance. Okay, now we take the input from the keyboard, and make a for loop which is run up to tolerance value. Okay. uh, and then we have to find out the value of the Lipton-Raphson's equation, given equation, which is x1 equals to x naught minus function of fx divided by differentiation of function of x naught. Okay. Now we get the value of x1, and if we need uh, to alter the value, then we go to the we check the absolute value of x1 minus x0, which is less than tolerance. If yes, then we do the swap. Otherwise we go to we display the desired result. Okay, now this is our uh, program, and I hope you already understand that the program very clearly. If you have any questions or if you have any query, please let me know in the live session or in the um, by messaging, which is available in the e-learning. And you have option which in e-learning you may pass a message to me through e-learning. Okay. Okay, that's all for today's week, and I hope all of you understand. Okay, take care and bye bye for this week.
And here's the output. If we build the program, or if we run the program, then we will see enter x naught tolerance and maximum number of iterations in the screen. Then we have to write down, or we have to give the values of x naught tolerance and maximum iterations. So here we have used 1.5 as the value of x naught tolerance, 0.00005, since we have to find out the value up to 5 decimal places, and maximum number of iteration 30. So after pressing enter, we will get this approximation. So here we can see that after fifth iteration we have got our root, and the root is 1.783769.